Children, now let us continue the chapter Coordinate Geometry. You learnt about the distance formula, section formula, midpoint formula, etc. Now let us discuss about the area of a triangle. In your earlier classes, you have studied how to calculate the area of a triangle when its base and corresponding altitude are given. That is, by using the formula, area of a triangle equals half into base into altitude. And also, you learnt the Heron's formula to find the area of a triangle when the sides of a triangle are given. That is, area of a triangle equals square root of s into s minus a into s minus b into s minus c, where s is a semi-perimeter. Area of a triangle, if the coordinates of the vertices of a triangle are given, is to be studied now. You could find the length of the three sides using the distance formula, and then you can use the Heron's formula to find the area of the triangle. But this could be tedious, particularly if the length of the sides are irrational numbers. So, now let us see if there is any easier way or not. Now, consider a triangle ABC whose vertices are A of coordinates x1, y1, B of coordinates x2, y2, and C of coordinates x3, y3. Let us draw the perpendiculars to the x-axis from A, B, C. They are AP from the point A, AP perpendicular to x-axis, and BQ perpendicular to x-axis, and also CR perpendicular to x-axis. Here you got three perpendiculars from the vertices of the triangle ABC. They are AP, BQ and CR respectively. Now here you got three trapezium. They are AB, QP, AB, QP and APRC, APRC and also BQRC. BQRC, that is the big trapezium here, that is big one. These are the three trapeziums you got. Now you know the formula to find the area of the trapezium, that is half of the product of sum of parallel sides and distance between them. That is half into sum of parallel sides into distance between the parallel sides. Now let us write what you have done here. You have drawn the perpendiculars AP, BQ and CR. So you write, draw AP, BQ and CR, AP, BQ and CR perpendicular to x-axis from the points ABC respectively. AP, BQ and CR perpendiculars from ABC respectively, from A, B, C respectively to the x-axis. X-axis. Therefore, the area of the triangle ABC area of the triangle ABC is equals to area of the trapezium ABQP plus area of trapezium APRC. Area of trapezium, this trapezium, this whole trapezium, plus area of the trapezium APCR, this whole trapezium, minus area of the trapezium BQRC you will get. That is, what is that? Area of the trapezium, this trapezium ABQP plus area of the trapezium ACRP minus area of the trapezium this. So find the area of all this trapezium in terms of the coordinates of the triangle, coordinates of the vertices of the triangle. So let us write. Then ABQP APRC and BQRC are all trapezia, are trapezia. Therefore you write, therefore here we said area of triangle ABC, area of the triangle ABC, area of triangle ABC equals what you can write? Area of trapezium ABQP, area of trapezium ABQP. What is that area? That is, this is the trapezium, area of the trapezium ABQP plus area of trapezium. So plus you write plus area of trapezium APRC. Where is that APRC? This is APRC. This is the trapezium APRC. Then minus what? Area of trapezium BQRC. Area of trapezium BQRC. Here sum of the trapezium means you will get the total area. Which area? This total area will be got here, will be calculated, and from that total area if you subtract the area of this trapezium, which trapezium BQRC, that is BQRC, then you will get the area of this triangle. Therefore, we know the formula to find the area of the trapezium. We know that area of trapezium equals what is that? Half into sum of parallel sides, sum of parallel sides into distance between them. Distance between them. Sum of parallel sides into distance between them. So let us write the formula for each. Therefore, area of triangle ABC. So the area of the first trapezium APQB is half into, you take that APQB, here the parallel sides are BQ and AP. Sum of the parallel side means area of trapezium APQP. Area of trapezium APQB is half into parallel sides BQ plus AP plus the distance between them QP. So you write half into BQ plus QAP, which are parallel sides. Distance between them is QP. Distance between them is QP plus half into the area of trapezium APRC. In the APRC, AP and RC are parallel sides. So you take half into AP plus RC. The distance between them is PR. So you write half into AP plus CR. Distance between them PR. Next plus half into, that is the area of the trapezium BQRC, that is minus, not plus. You take minus. You have to subtract that area of trapezium BQRC. In BQRC, the parallel sides are these two, that is BQ and CR. BQ plus CR, half into BQ plus CR. Distance between them is QR. So you write minus half into BQ plus CR, BQ plus CR into QR. Then you write half into BQ plus AP, BQ here. The distance BQ plus AP, BQ is Y2 and AP is Y1. AP is Y1. So you take Y2 plus Y1. PQ is, here P is X1 and Q is X2. So you take X1 minus X2. Distance is X1 minus X2. That is from QP minus OQ. It is QP is X1 and QO is X2. So you take X1 minus X2. Then plus half AP. AP is this one and coordinates is Y1. AP is Y1 and CR is Y3. So you write Y1 plus Y3. AP plus CR is Y1 plus Y3 and half into AP. AP means Y coordinate is Y1 plus CR. Here the Y coordinate is Y3. Y1 plus Y3. Then PR that you have to find out, that is OR minus what you have to take, this QR. OR minus QR. OR minus means OR is, that is X3 and OR minus OP you take. OR minus OP is, that is X1. X3 minus X1 you take. Take X3 minus X1 minus half into BQ. BQ is, that is the y coordinate is y2, then plus CR is y3 into QR is, that is OR minus OQ. OR is x3, OQ is x2. So you take x3 minus x2, then you remove half common, half into x1 y2 minus x2 y1 plus y1 x3 minus y3 x1 plus y2 x3 minus y2 x2 plus y3 x3 minus y3 x2. y2 x3 you got here, then y3 x3 this is, y2 x2 this is, and y3 x2 you got. That is by term multiplication. Multiply first term this and this, again this with this and this, again this with this with this, again this into this into this into this into this. In this way you got the product by term multiplication. Then 1 by 2 into, that equals half into, write the product here, y2 into x1, that is y2 x1, then y2 into x2 minus y2 x2, then y1 into x1 plus y1 x1, then y1 into x2 minus y1 x2 plus y1 into x3 y1 x3, y1 into minus x1, that is minus y1 x1, then y3 into x3 plus y3 x3, and y3 into x1 minus y3 into x1. Then here minus is there, then minus of y2 into x3 is y2 x3, and y2 of minus y2 into x2, then plus y3 into x3 minus y3 x2. So now write this half into here. Now you write half into here, the bracket must be opened, so you write the remaining terms from here to here, you write it as it is, that is y2 x1 minus y2 x2 plus y1 x1 minus y1 x2 plus y1 x3 minus y1 x1 plus y3 x3 minus y3 x1, open the bracket now, it becomes minus y2 x3, and minus becomes plus y2 x2, and minus plus becomes minus y3 x3, and minus becomes plus y3 x2. Then here like terms are there, you know that y1 x1 plus y1 x1 minus y1 x1 cancels, and minus y2 x2 plus y2 x2 becomes cancels. Then y3 x3 minus y3 x3 cancels. Now bring x1 x1 together. Where is x1 x1? Here is x1 and here is x1. Bring them together. That is y2 x1 minus y3 x1. Then x2 x2 together. x2 x2 is here. Bring them together. Plus y3 x2 minus y1 x2. Then y3 x3 x3 together. So what is that? y1 x3, and where is x3? y1 x3 you got, and one more here it is, minus y2 x3. Then you write half into, remove the common x1 x1 here, half is not required here. That is, write x1 into, this is y2 minus y3. x1 into y2 minus y3, plus out of this you remove x2 into y2 minus y3 minus y1, y3 minus y1, plus x3 is there, remove that outside, x3 into y1 minus y2, y1 minus y2. Then therefore area of triangle ABC equals, area of triangle ABC equals half into, what you got? First term is x1 into y2 minus y3. See here 1 2 3. Here x1 and y2 minus y3 you have. Next plus second term is x2, then y3 minus y1, 2 3 1. Then plus x3 y1 minus y2, x3 into y1 minus y2, 3 1 2. Here if the coordinates of the three vertices of the triangles are given, then the area of the triangle equals half into x1 into y2 minus y3 plus x2 into y3 minus y1 plus x3 into y1 minus y2. Here x1 y1, x2 y2, x3 y3 are the coordinates of A, B, C respectively. So this is the formula to find the area of the triangle. That is, area of triangle ABC equals half into x1 into y2 minus y3 plus x2 into y3 minus y1 plus x3 into y1 minus y2.